January 17, 1943. Guadalcanal, Solomon Islands. The rain falls in sheets across the jungle canopy, turning red volcanic soil into rivers of mud that swallow boots and equipment alike. Lieutenant James Pritchard of the 810th Engineer Aviation Battalion stands knee-deep in what was supposed to be an airstrip, watching another C-47 transport circle overhead, unable to land. The aircraft banks sharply, fuel running low, forced to attempt the treacherous journey back to Espiritu Santo. 300 miles of open ocean, Japanese fighters prowling every mile. Pritchard knows what this means. No medical supplies for the field hospital where men are dying from infected wounds. No ammunition for the Marines holding the perimeter against nightly Japanese infiltrations. No reinforcements to replace the exhausted troops who haven't slept in 72 hours. He drives his shovel into the mud once more, and it disappears entirely, sucked down by the insatiable earth. The sound is almost obscene in its finality. Somewhere in the distance, artillery echoes through dense vegetation. Japanese guns from the hills, a reminder that holding territory means nothing if you cannot supply it. The Americans have captured the island, but they are losing the battle against the jungle itself. Pritchard wipes rain from his face with a mud-caked hand and looks at the men around him. They are covered head to toe in red volcanic mud, indistinguishable from the earth they're trying to tame. Some have been working for 16 hours straight, trying to grade and compact the soil, trying to create something solid enough to support the weight of aircraft. But the rain keeps coming, and the mud keeps winning. A bulldozer sits abandoned 30 yards away, its treads buried so deep that 3 other bulldozers couldn't pull it free. The jungle is eating everything: equipment, supplies, hope. Pritchard has been in the Pacific for 9 months. He has built roads that disappeared overnight, constructed bridges that washed away in flash floods, laid foundations that sank into the earth as if the island itself was rejecting American presence. He is an engineer, trained at Cornell, educated in the principles of soil mechanics and structural integrity. Yet nothing in his education prepared him for this. An environment that actively, aggressively, relentlessly destroys everything man tries to build. That night, Pritchard would write in his diary, a leather-bound journal he kept throughout the war, now preserved by his grandson. The entry was brief, uncharacteristically bitter. Watched 6 aircraft circle today. Couldn't land. 2 ran out of fuel trying to reach Espiritu. Crews lost. We're not losing to the Japanese. We're losing to physics, to mud. How do you fight mud with rifles and courage? This moment, repeated across dozens of Pacific islands in early 1943, represented a crisis that threatened to undermine the entire Allied offensive against Japan. The United States military had achieved the impossible, projecting power across 7,000 miles of ocean, establishing footholds on enemy-held islands, pushing back an empire that had conquered half of Asia in less than 5 years. Yet they found themselves trapped by a problem as old as warfare itself: logistics. An army without supply lines is merely a collection of men waiting to die. Aircraft without runways are expensive paperweights sitting uselessly on carrier decks or distant rear area bases. The Japanese had spent decades fortifying their island bases with concrete airstrips and permanent installations, built by tens of thousands of conscripted laborers and prisoners of war. The Americans, advancing rapidly across the Pacific in a strategy that demanded speed and momentum, had only mud, coral, and dense jungle that grew back faster than it could be cleared. What could turn mud into runway? What could defeat an environment that consumed concrete and swallowed steel? The answer would come not from the battlefield, but from a warehouse in Pittsburgh. The men of the Army Corps of Engineers had expected to build, to construct, to impose American industrial might upon the landscape with the same confidence that had tamed a continent. They arrived in the Pacific with swagger born from a nation that had conquered deserts and mountains, that had built the Hoover Dam and the Golden Gate Bridge. They brought bulldozers manufactured in Peoria, graders from Caterpillar, cement mixers from Chicago. They brought the full weight of American engineering expertise, the accumulated knowledge of a civilization that had built more in 1 century than most empires managed in a millennium. They expected the Pacific Islands to yield to their expertise the way the American West had yielded to railroads and dams. What they encountered was an environment that rejected every assumption they had made. The soil itself seemed alive, shifting and settling according to rules that defied conventional engineering principles. Equipment rusted within weeks, consumed by humidity so intense that metal literally dripped with condensation. Timber rotted before structures could be completed. Roads built with crushed coral became impassable quagmires during monsoon season, the coral dissolving into slurry that had the consistency of wet concrete and the load-bearing capacity of soup. And the Japanese, entrenched in their fortified positions, watched and waited, knowing that time and nature were their most powerful allies. They didn't need to defeat the Americans in battle, they just needed to wait for the jungle to do it for them. In the spring of 1941, 2 full years before Pritchard would stand helpless in Guadalcanal's mud, a group of engineers at Carnegie Illinois Steel Corporation in Pittsburgh received an unusual request from the Army Corps of Engineers. The military needed a portable runway system, something that could be transported in pieces and assembled quickly to create a functional airstrip on unprepared ground. But the requirements were unprecedented, bordering on impossible. The system had to support fully loaded bombers weighing 20 tons or more. It had to function from Arctic tundra to tropical jungle. It had to resist corrosion from salt water, withstand repeated impacts from aircraft landings, and remain functional even when damaged. Most impossibly, it had to be manufacturable in massive quantities. Millions of square feet of matting produced fast enough to supply a rapidly advancing military campaign across 2 theaters simultaneously. The design team, led by engineer Eugene Raybould and metallurgist James Marston, spent months testing configurations. They constructed mock runways and drove trucks over them until the steel buckled. They simulated tropical rainfall with fire hoses running for days, Arctic cold with industrial refrigeration units, battle damage with sledgehammers and explosives. Each failure brought refinements. Each refinement was tested to destruction. By August 1941, 4 months before Pearl Harbor would transform America from observer to combatant, they had a prototype that worked. The Marston Mat, named after James Marston, who solved the critical locking mechanism, was a perforated steel plank measuring 10 feet long, 15 inches wide, constructed from 14-gauge steel. Each plank weighed exactly 66 pounds, heavy enough to be substantial, light enough for 2 men to carry. The surface was pierced with hundreds of circular holes, each precisely 1 3/8 inches in diameter, sized to provide maximum drainage without compromising strength. The edges featured an ingenious hook-and-eye interlocking system that allowed planks to be joined into a continuous surface that could flex under load without coming apart. The design was elegant in its simplicity. No bolts, no welds, no specialized fasteners. 2 men could connect planks by simply aligning the edges and stepping on the connection point. Click. Yet beneath that simplicity lay remarkable precision. The hooks had to withstand 30-ton aircraft landing at 100 miles per hour, yet connect without special tools. The steel required specific heat treatment to achieve perfect balance. Too hard, and it would crack. Too soft, and it would deform. Production began at Carnegie Illinois plants in Pittsburgh and Gary, Indiana, in late 1941. The timing was eerily prescient. First major orders placed in October, just weeks before Pearl Harbor. The steel mills, already running at capacity for Lend-Lease shipments, now dedicated entire production lines to manufacturing these peculiar perforated planks. Quality control was absolute. A single defective plank could cause aircraft to crash. Every plank was inspected, every hundredth destructively tested. By early 1942, production reached 10,000 planks per day. By mid-1943, daily output exceeded 50,000. More than 300 tons of processed steel every single day, dedicated solely to building temporary runways. The first large-scale deployment occurred in North Africa in late 1942, during Operation Torch. American engineers discovered the matting could transform empty desert into functional airstrip in less than 48 hours. A crew of 200 men working in rotating shifts could lay enough matting to accommodate an entire fighter squadron before the sun set twice. The process became ritualistic in its efficiency. Engineers surveyed terrain, marking rectangular strips aligned with prevailing winds. Bulldozers scraped away top layers of sand. The matting arrived on trucks in bundles of 20 planks. Teams of 2 men carried each plank to position, lined up interlocking mechanisms, then stepped simultaneously on the connection point. Click, 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 a mechanical symphony of progress. Within hours, sand disappeared beneath carpet of steel, perforated and gleaming. The first aircraft to land was a C-47 carrying General Dwight Eisenhower. When he stepped out and looked at the steel runway that hadn't existed 3 days earlier, he said nothing, just nodded slowly. Those present said they could see him doing calculations in his head, understanding immediately what this technology meant for the war's future. But North Africa was forgiving compared to the Pacific. The desert was dry, stable, predictable. The jungle was alive, hostile, relentlessly destructive in ways that seemed almost personal. When Marston Matting arrived at Guadalcanal in January 1943, Pritchard and his engineers faced their first true test. The Japanese had systematically destroyed Henderson Field before retreating, and months of bombardment had left the area cratered and unstable. Engineers began laying matting over damaged coral on January 18th, working through the night under threat of Japanese air raids. They had to work fast. Intelligence indicated a major offensive was being planned, and air superiority would determine its success or failure. The tropical environment presented unique challenges. Intense humidity caused steel to sweat constantly, creating slippery surfaces. Red volcanic soil seeped through drainage holes, forming abrasive paste that wore down steel like sandpaper. Tropical downpours overwhelmed drainage systems, creating pools of standing water that had to be manually swept away. Working on the matting during midday was like working on a griddle. Metal absorbed tropical sun and became hot enough to burn exposed skin. Men learned to work in long sleeves despite heat, accepting discomfort over agony. At night, temperature dropped only slightly, but humidity increased, and steel became slick with condensation. The jungle pressed in from all sides. Insects were everywhere. Mosquitoes carrying malaria, flies spreading dysentery, spiders hiding in equipment, leeches in standing water. Yet despite these challenges, the matting worked. It worked better than anyone had dared hope. On January 24, 1943, just 7 days after Pritchard had watched helplessly as aircraft circled unable to land, a squadron of Marine F-4U Corsairs touched down on the completed runway at Henderson Field. The sound of their wheels hitting steel was distinctive, a sharp, ringing contact rather than the soft thump of rubber on coral. The pilots reported that steel planking provided better traction and stability than many permanent concrete runways they had used at training bases back in the United States. Within a week, the airstrip was handling more than 200 aircraft operations per day. Fighters, dive bombers, torpedo bombers, reconnaissance planes, transports bringing supplies and evacuating wounded. The Japanese, observing from jungle-covered hills, their artillery carefully hidden but constantly watching, could only watch in frustrated disbelief as American air power multiplied exponentially overnight. They had counted on the rainy season to ground American aircraft to give them time to regroup. Instead, They watched American planes flying in conditions that would have been impossible weeks earlier. On February 3, 1943, Pritchard made another entry in his diary. The tone had changed completely. The steel matting works. Watched a C-47 medevac flight land and take off today, carrying wounded Marines to rear hospitals. 3 weeks ago, impossible. Those Marines would have died. Spent the evening trying to calculate how many lives will be saved by the ability to land aircraft in impossible places. I can't. The numbers are too large, but I know it's significant. I know this ugly steel, so mundane and industrial, represents something profound about who we are. The strategic implications were immediately apparent throughout the Pacific. Admiral William Halsey sent a telegram to Admiral Chester Nimitz that was preserved in naval records. Steel matting transforms island hopping from theory to reality. Can now establish air superiority within 1 week of landing. Recommend maximum priority. Nimitz forwarded it to Washington with his own notation. Concur completely. This changes everything. And it did. Island hopping became suddenly viable on an accelerated timeline. Previously, capturing an island was only the first step in a months-long process of establishing air superiority. With Marston matting, the entire timeline collapsed. An island could be captured on Monday and operational by Friday. Aircraft that had been flying from carriers or distant bases could suddenly operate from forward positions, extending their combat radius by hundreds of miles and increasing payload capacity dramatically. The Japanese, who had built their defensive strategy around the assumption that each American advance would be slow and methodical, found themselves confronting an enemy that seemed to materialize simultaneously at multiple locations, supported by air power that appeared with impossible speed. Their intelligence services became almost obsessed with understanding how Americans were building airstrips so quickly. They knew about the steel matting. Pieces had been captured and analyzed, sent to Japan for study. But knowing about it and countering it were entirely different problems. Japan's industrial capacity, already strained, couldn't possibly produce similar matting in comparable quantities. By the end of 1943, more than 2 million square feet of Marston matting had been shipped to the Pacific Theater alone, enough to cover nearly 50 football fields with perforated steel. Each shipment required careful planning. The matting was heavy, space-consuming, and had to compete for limited cargo space with ammunition, fuel, food, medical supplies. Yet commanders consistently prioritized it, recognizing that control of the air was the prerequisite for everything else. The matting traveled by Liberty ship across the vast Pacific, stacked in holds or lashed to decks, then transferred to landing craft for the final journey to contested beachheads. Engineers became expert at rapidly assembling runways under fire. On Tarawa, one of the bloodiest battles, engineers began laying matting while Japanese snipers were still active. They worked in shifts, some laying matting while others provided security. 3 engineers were killed by sniper fire during runway construction. Their bodies were moved aside and the work continued. The runway was completed 72 hours after the island was declared secure. On Saipan, engineers laid matting under Japanese artillery fire, enemy guns targeting the obvious concentration of activity. They learned to work in dispersed teams, to take cover at the first whistle of incoming shells, to resume work immediately after explosions. The calculus was brutal but simple. The runway had to be built, whatever the cost, because without it, the cost would be higher. On Iwo Jima, perhaps the most famous American battle in the Pacific, engineers used Marston matting to quickly repair volcanic ash runways damaged by Japanese artillery, often working within direct range of enemy guns. The steady rhythm of steel planks being connected, click, 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 was punctuated by the boom of artillery and scream of incoming shells. Men died doing this work, killed by shell fire while connecting steel planks. Their sacrifice was recognized as being as important as any combat action because without runways, The Marines fighting in volcanic ash and caves would be unsupported, isolated, doomed. The Japanese soldiers who witnessed this experienced a profound cognitive dissonance that shook the ideological foundations they had been taught since childhood. They had been told that Americans were soft, that they lacked warrior spirit, that reliance on material abundance was weakness. Yet here, they observed American engineers not only enduring hardship, but systematically eliminating it through engineering solutions. American soldiers didn't accept impossible terrain. They transformed it. They didn't adapt to the jungle. They paved over it with steel. A Japanese lieutenant, captured on Bougainville in November 1943, was interrogated extensively. His responses, preserved in American intelligence records, reveal psychological state that interrogators described as depressed resignation mixed with genuine admiration. He described watching American engineers transform impenetrable jungle into functional airstrip in less than a week. He noted that Japanese forces had spent 3 months constructing a crude runway from coral and logs, using hundreds of laborers, only to watch American engineers create a superior airstrip in days using a fraction of the manpower. The interrogator's notes record the prisoner's final comment verbatim. "We were told that American soldiers are weak and afraid of hardship. But when they encounter hardship, they do not try to overcome it with spirit. They simply remove it. They bring machines to cut the jungle, steel to cover the mud, ships to bring supplies, aircraft to bring wounded men to hospitals. They do not ask their soldiers to be strong. They build systems that make strength unnecessary." How can spiritual warriors compete with this? This realization would be repeated by thousands of Japanese soldiers throughout the Pacific as they encountered American engineering capabilities. The Marston Mat became, for many Japanese troops, the symbol of why Japan was losing the war. Not because Japanese soldiers weren't brave or dedicated enough, but because they were fighting an industrial system that could mobilize resources on a scale their empire simply couldn't match. Every perforated steel plank was physical manifestation of American industrial might, of an economic system that produced such abundance that steel could be stamped into millions of runway planks and shipped across 7,000 miles of ocean, and used once then, abandoned when forces moved forward. This was the deeper symbolism the Marston Mat represented, not just military equipment, but a rebuke to fascist ideology. Fascism glorified sacrifice, spiritual strength, subordination of individual comfort to collective goals. The Marston Mat represented the opposite philosophy: pragmatism, engineering solutions, application of industrial abundance to eliminate rather than endure hardship. When American engineers encountered an impassable swamp, their first instinct wasn't to wade through it or build character by suffering through it. It was to cover it with steel matting and move on to the next problem. This mentality, deeply pragmatic and utilitarian, was enabled by an economic system that could treat steel as almost disposable commodity. By 1944, Marston matting had been deployed across virtually every American-held island in the Pacific. Engineers learned to adapt the design to local conditions in ways original designers hadn't anticipated. In Arctic Aleutian Islands, they laid matting directly on permafrost, which provided excellent stable base. In coral atolls, engineers created artificial islands by dredging coral and piling it into shallow areas, then covering unstable surface with matting to create instant airstrips that essentially floated on loose fill. In mountainous New Guinea, they carved strips into hillsides at impossible angles, using matting to stabilize loose soil and prevent erosion. In the Philippines, during the campaign to recapture the islands in late 1944, engineers performed perhaps the most impressive feat. They laid matting directly over rice paddies, creating runways that essentially floated on waterlogged mud 10 feet deep. The matting distributed aircraft weight across enough area that even soft substrate could support them. Conventional engineering wisdom said it was impossible. You can't build runway on mud. But American engineers did it anyway, Because the alternative was not having a runway. And not having a runway meant not having air support. And not having air support meant men dying unnecessarily. The tonnage figures tell their own story of incredible industrial mobilization. By the end of World War II in August 1945, American industry had produced more than 4 million tons of Marston matting, enough steel to build approximately 40 Iowa-class battleships, or equip 200 armored divisions with Sherman tanks. Yet commanders considered it worthwhile, understanding that air superiority was the foundation of Allied victory, and air superiority required runways. The matting enabled construction of more than 300 airstrips in the Pacific Theater alone. The strategic bombing campaign against Japanese home islands, which ultimately contributed to forcing Japan's surrender without full-scale invasion, was made possible by a chain of island airstrips connected by these humble perforated steel planks. The B-29 superfortresses that firebombed Tokyo and dropped atomic bombs on Hiroshima and Nagasaki flew from runways built with Marston matting on Saipan and Tinian. German soldiers, encountering Marston matting during Allied advance across Europe, had similar reactions of disbelief and demoralization. The Wehrmacht had spent years building elaborate fortifications and permanent airfields across occupied Europe. They assumed any Allied invasion would require months of preparation. Instead, they watched as American engineers transformed French fields into operational airstrips within days of D-Day landings. A German officer, captured near St. Lo in July 1944, later wrote in his diary about the psychological impact. He described watching from a distant hilltop as American troops laid what he initially thought was a road, only to realize with horror they were constructing a runway. Within 48 hours, the runway was complete and hosting aircraft that immediately began supporting Allied ground forces. He wrote that seeing this made him understand, perhaps for the first time, that Germany had already lost, not due to any failure of German courage or tactics, but because they were fighting an enemy with effectively unlimited resources and engineering capability to deploy them with devastating efficiency. This realization, that material abundance could be weaponized, that logistics could be as decisive as bravery, represented profound ideological challenge to fascist military thinking. Both Nazi Germany and Imperial Japan had built their philosophies around concept of will triumphant, the idea that determined people could overcome any material disadvantage through spiritual strength and sacrifice. The Marston Mat, mundane and utilitarian, demolished this ideology through sheer practical effectiveness. It demonstrated that wars were won not by the side with strongest belief system, but by the side with most robust supply chain. The human cost of this engineering marvel was measured not just in lives saved, but in futures created. Each runway shortened the war, reducing the number of soldiers who would die in prolonged campaigns. Each ton of supplies delivered to forward positions meant fewer men suffering from preventable diseases, fewer wounded soldiers dying for lack of medical evacuation. Lieutenant Pritchard survived the war. His final diary entry, dated August 16, 1945, the day after Japan's surrender, was characteristically brief. "It's over. We won. Not because we were braver. Because we could build. Because we could supply. Because we turned mud into runways and impossibility into routine. That's the American way of war." The technical evolution of Marston matting continued throughout the war. Engineers developed lighter versions for areas where transport capacity was limited, heavier versions for runways supporting massive B-29 superfortresses. They created specialized sections for taxiways and parking areas, repair shops, and fuel depots. The basic design spawned variants. The British developed their own version called Sommerfeld tracking. The Soviets created similar systems based on captured American samples. But the American version remained the standard, the benchmark against which all other portable runway systems were measured. When the war ended, Engineers stockpiled millions of square feet of Marston matting in anticipation of the planned invasion of Japan. The invasion never occurred. The atomic bombs and Soviet declaration of war forced Japan's surrender in August. The stockpiled matting found new uses in the post-war period. It was used to construct emergency airstrips across Europe and Asia, to rebuild damaged infrastructure, to create temporary roads and bridges. Surplus matting was sold to civilian contractors and used in construction projects worldwide. Some is still in use today, nearly 80 years later, testament to engineering excellence of its design. The legacy extends far beyond immediate wartime application. Modern military engineers still use portable runway systems based on the same fundamental principles, interlocking panels rapidly assembled to create stable surfaces on unprepared ground. Contemporary versions use aluminum alloys or composite materials, are lighter and stronger, incorporate lessons learned from decades of use. But the conceptual foundation remains unchanged. The recognition that mobility and logistics are as important as firepower. That ability to project power depends on ability to supply it. That engineering ingenuity can overcome environmental obstacles that would otherwise be insurmountable. What is the sound of victory? Perhaps it's not the thunder of guns or the roar of engines. Perhaps it's something quieter, more prosaic. Perhaps it's the click of steel on steel, repeated millions of times across thousands of miles. The sound of engineers transforming impossible terrain into strategic assets. The sound of democracy proving that free societies can mobilize resources more effectively than totalitarian regimes. The perforated steel planks that allowed Lieutenant Pritchard and thousands of engineers like him to build airstrips in impossible places represented more than clever metallurgy. They embodied a worldview, a way of approaching problems that was distinctly American in character. When confronted with an obstacle, the American response was not to accept it as fate or overcome it through sheer willpower, but to engineer a solution, to mobilize industrial resources, to treat the problem as a design challenge rather than a test of spirit. This mentality, pragmatic and materialistic, was enabled by an economic system that could produce abundance, that could treat steel as something to be stamped into millions of perforated planks and shipped across oceans. The clicking sound of interlocking Marston mats, echoing across jungle clearings and desert wastes, was the sound of American industrial might being applied to problems of warfare. It was the sound of an economic system demonstrating its superiority, not through ideology or propaganda, but through practical results. It was the sound of engineers transforming impossible terrain into strategic assets. Each click represented two planks joining together, 66 pounds of steel connecting to 66 pounds of steel, multiplied by millions until the cumulative weight became impossible to resist. When the war ended and soldiers returned home, most forgot about the Marston matting they had assembled in distant jungles and deserts. It was just another piece of equipment, another task completed in the long list of duties that made up military service. But the engineers who designed it, who solved the metallurgical and mechanical challenges, who figured out how to manufacture it by the millions and ship it across the world, they had changed warfare forever. They had demonstrated that logistics could be as decisive as tactics, that engineering could be as important as courage, that the ability to build could be as powerful as the ability to destroy. The runways have long since been abandoned, reclaimed by jungle and desert, the steel slowly rusting back into the earth from which it came. But the principle endures, that free societies, when properly motivated, can mobilize resources and solve problems at a scale that authoritarian regimes cannot match. That abundance, far from being weakness, is a form of power. That the ability to land aircraft in impossible places, to supply soldiers in unreachable locations, to build infrastructure where none existed, these capabilities, mundane and logistical though they may be, are what ultimately decide the fate of nations. and in some forgotten corner of a Pacific island, perhaps a few perforated steel planks remain, half buried in volcanic soil, holes still visible through decades of rust, a silent monument to the engineers who understood that winning wars requires not just brave soldiers, but also the ability to get those soldiers supplied, supported, and equipped, no matter how impossible the terrain, no matter how unforgiving the environment, no matter what obstacles stand in the way. A monument to the truth that victory belongs not to those who can endure the most suffering, but to those who can eliminate suffering through ingenuity. That is the legacy of the Marston Mat. That is the sound of democracy at war. Not the clash of ideologies, but the quiet, relentless click of steel solving problems that spirit alone never could.